Hello again, everyone. Thank you for those who subscribe this channel. If you haven't done so, it's time to click that bell to subscribe this channel to continue support this channel grow. All right, thank you. I'm going to start talking about a little difficult question. So we have an inequality divided into two parts. The first one is we need a proof. The x always greater than log x, natural log, when x is greater than 0. Then we're going to use the mathematical induction to prove that equation or the inequality always true. So I already pre-solved that. I'm going to go through the solutions with you. All right, step one, what I'll do is in order to prove that's the true, I'm going to move the log x to the left. I want to prove that's equal to greater than 0. So what I do, I'm going to let the fx equal to that. In order to prove that fx always greater than 0, so I need to find the stationary point or turning point. So I'm going to differentiate the fx. So then I found the stationary point is at 1 and 1. So that's the stationary. So x equal to 1. So that's the stationary point. So then we're going to see if it's a graph, it's always from the right-hand side of that is always go up. So if that's the case, so the fx will be always greater than 0. So how do we do that? So if we're going to, then we're going to differentiate. Let's differentiate. So the different double derivative, so stationary point means this is the minimum. But we need to prove if it's a minimum. So we need to say the second derivative is x to the power of -2, which is 1 over x squared. Now, when x is positive, so that means second derivative always positive. So therefore, the graph is, that point is the minimum stationary point. So it means always concave up. So therefore, the fx is always great because greater than the minimum point, because that's the minimum point. So the fx is always greater than minimum point. So that means they're always above that point. So regardless of what's x. So therefore, we can see f1 is greater equal to 1. So 1 is more than 0. So therefore, fx always positive. If it's a positive, we move that one to the right. So become x greater than log x. So for any x, as long as it's positive. So what I'll do is I'm going to choose a left-hand side become log e to the power of x. So therefore, we can conclude the e to the power of x always greater than x. So that's the same conclusion. So we're going to use that conclusion to do the second question, be number 2. So we also can say if I want to square both sides, so be 2x is greater than x squared. So that's another equation we're going to use for the next step. So we're going to prove that's the inequality. We're going to prove that's the inequality. So let's using the n equal to the minimum. So n is the positive integer. So we call n is the minimum is 1. So let's try n equal to 1. Left-hand side is e squared. Right-hand side is 1. So e squared is greater than 1. So therefore, statement is true when n equal to 1. So that's step 1's proved. we're assuming n equal to k, the statement is true, so which is replace n with k greater than k factorial to the power of 2. So now we're going to let when equal to k plus 1, the left-hand side is k plus 1 squared plus k plus 1, expanding the bracket. So we got that plus this. So I'm going to separate into two e-based index. The first one, that's the one I'm going to use the summation. So that one is greater than k exclamation to the power of 2. And that one, because they're both positive, so therefore we write down this one to the right. Now, according to the from equation number 1, we got e to the power of x greater than x. So e to the power of 2x must be greater than x squared. So therefore, this is a 2x. So therefore, this will be greater than k plus 1 to the power of 2. So we replace that. That's the x. So that's the x. That's the x. So then we put together k plus 1, k factorial, then squared, will become k plus 1 factorial squared. So that's equal to right. So therefore, the statement is true when k plus n equal to k plus 1. So the statement is true for any n, as long as a positive integer. So QUD. All right, that's a pretty interesting question and not easy. So thanks for watching. If you enjoyed the video, please give us the thumbs up. Thank you again. I'll see you next video. Bye.